my name is Mohammed Abdullah, and today we're going to be doing an experiment over density. So you might be asking, what is density? How does it work? Why do we need to know it? Well, it turns out that density has a few key applications in real life. So in real life, oftentimes ships use the principle of density to stay afloat. And here we have what appears to be otherwise rainbow colored water. You can see here that we have blue at the bottom, purple in the middle, orange, and then yellow. And same thing for here, we have blue and then purple, pink, and red. And we also have the same thing over here. So the question is, how do these different colored waters stack on top of each other and not mix? Well, that is actually through the principle of density. So let's define density and perform this experiment. So density is best defined as the mass per unit volume. So the mass of the substance over the volume of the solution. And mass is often measured as grams and the volume is measured at milliliters. So the overall unit would be grams per milliliter. So we're going to be performing the experiment and then we're going to come back and answer a few key concept questions. So to perform this experiment, you need a few key things. The first thing you need is some sugar, some cups, some food coloring, and a dropper. So let me move these out of the way. So we have these 4 cups, and the idea is that we're going to stack from most dense to least dense. So let's take our sugar. Let's not put any sugar in here. And for this first cup right here, let's put 1 tablespoon of sugar. In this third cup, we'll put 2 tablespoons of sugar. And then in this final cup, we'll put 3 tablespoons of sugar. That's 1, 2, and 3. So what we've effectively done is put a whole bunch of sugar in this one, not much sugar in this one. And what we're going to do now is that we're going to add an equivalent volume of water to all of these. So we're going to add 1/3 cup of water to all of these. So a 1/3 cup of water goes into here. A 1/3 cup of water goes into here. A 1/3 cup of water goes into here. And finally, a 1/3 cup of water goes into here. So remember, this is the 3 tablespoon solution, 2 tablespoon solution, 1 tablespoon solution, and 0 tablespoon solution. So now what we're going to do is we're going to mix the solutions until they appear clear. So here, let's mix it up a bit. And now for the 2 tablespoon solution. For the 1 tablespoon solution, and this one didn't have any sugar, so we don't need to mix. So now that we have these together, let us add food coloring. So we have blue food coloring, yellow food coloring, green food coloring, and red food coloring. So let's add, let's say 2 to 3 drops of blue food coloring in the 3 tablespoon solution. Okay. And then 2 to 3 tablespoons of yellow food coloring. And then 2 to 3 drops of green food coloring. Need some more. There you go. And finally, red food coloring. So now we see we have a blue, yellow, green, and red. So now what we're going to do is we're going to transfer these 4 colors into this test tube right here, and we're going to see if we can actually manipulate the principles of density to put the highest density blue solution at the bottom and stack them in an ascending order. So let's try that. And for that I'll be using this dropper, really small 1 milliliter. All right. Alright, so that is the blue, the most dense. Let's set that aside. Now let's do green. And you can see that 2 layers are starting to form the bottom blue layer and the top yellow layer. So they are not mixing, they're staying separate. And once again, they're staying separate due to the principles of density. Alright, now we're done with yellow. Let's move on to green. A little bit more. Finally, let's move on to red. And that should be enough. So now if you look at this vial in closer detail, you'll see that the blue, or the most dense layer, was at the bottom, and it was the most dense because we added a total of 3 tablespoons of sugar. This was followed by the yellow that you can see in the middle, then green, and then red. And red floated at the top because all we added was water. We did not add a single drop of sugar. So that's how you perform a density color experiment. Now let's move on and let's perform a concept check to see if you understand the fundamental principles behind density. So The first question would be to rank the following colors from most dense with a 1 to least dense 4. So I'd encourage you guys to pause the video and try to figure it out, and then come back together and see if you get it. Alright, so from here we can see that the blue layer was at the bottom, which indicates that we must have added a whole bunch of tablespoons of sugar. So we would say the blue layer is most dense. And then what comes after that? Well, that would be the green layer. And then right after that, the orange layer. And then finally the red layer. Alright, so in this case, the most dense solution was the blue one, and then the least dense solution was the red one. And that's kind of why we're using these food colorings, because you could make this sugar water solution and stack the different waters on top of each other, but you can't really see what the different densities are. Using food colorings, we're able to use them as an indicator and kind of mark them. So let's move on to the second question right here. Once again, rank the following from most dense to least dense. So in here you can see it's kind of a reversed order of the experiment we did. So the most dense would be red, then orange, then green, and finally blue. So once again, knowing that over here there's going to be the highest density, and knowing here there's going to be the least density, we're just putting water, really, 1/3 cup of water, nothing else, no sugar. And finally, how much water did I add in this experiment to keep the volume constant? Well, if you remember, we added 1/3 cup of water. And you might be asking, oh, Mohammed, why are you asking how many cups of water we add? Does it matter? Well, it does matter right here. In the density equation, it's mass over volume. The thing we're keeping constant is the volume, right? So that's the independent variable. We're keeping this constant, and we're measuring changes in the dependent variable, which is the mass right here. So we're trying to see, okay, if we add different amounts of or different tablespoons of sugar, what's going to happen? So we can see that by keeping the volume constant, by changing the amount of sugar we're adding, we can fundamentally mess around with the principles of density. And this is at the most basic level you can perform density experiments. At higher levels and throughout high school and college, you'll be able to see how ships stay afloat through the concepts of buoyancy and Archimedes' law and all that other good stuff. So this concludes my experiment. Thank you guys so much for watching, and a special thank you to Dr. Parker and UHD Scholars Academy for making this possible. Thank you very much.